Welcome to another GC Basic demonstration video for the 16F legacy chip family. Let's get started on this video. This is part 6 of the suite of videos, and this is focusing on using the reset switch. So like and subscribe the video, let it run all the way through, give us a thumbs up, I'd be very grateful, thank you. So using the reset switch. Number 6, it's quite important to understand how this operates and a quick way to understand the settings. So GC Basic is an open source compiler for the PIC AVR and LGT microcontrollers, supports 16F. These programs and this approach can be used on any of the legacy chips that do not have PPS. And I'll show you a really quick way to figure out whether a chip's PPS. So I'm assuming that you've installed the GC Basic software and the IDE, your programming software is working, you've tested that PIC. You have 4 LEDs, a pot, and you have some switches connected. We'll talk about where they're connected in a moment. I'm using this board. It's a PICDEM2 Plus demonstration board. They're very cheap, huge amount of capabilities. Fantastic for people coming into this new. These are 15 British pounds, just short of $20. I mean, so cheap and so much you can do, so many sensors. So we're going to be using number 9, some 4 LEDs, number 7, the switches, and the potentiometer. No, we're not going to use that actually, but that's what we're using, and it looks like this. Here's mine. It is sitting there waiting for your enjoyment. So this time we're going to press the reset switch, and you might go, oh, and we might push this button here. Hey, look, it's working, but that's how it was left from the last video. But we're going to change the functionality. So we're going to use the master clear. The master clear has two functions, but we're going to show you how that can be changed and that behavior can be changed. These boards have RE3, which is that top right-hand one on this particular type of chip. You must check your data sheet. It's pulled high through a 10K resistor and a switch. And that switch, when I push it, will go low. And when it goes low, the chip will reset. Or not, as the case may be. That is the trick we're going to be using. We can make it an input by changing a particular characteristic of the chip. This diagram hasn't changed because I've got the switch on port. I've got the switch on, my microphone's beeping. I've got the switch on port A4, but I've also got this switch on port E3, and that's top and bottom. Do you want me to draw it? I will. Make sure it's quite clear. Here and here. There is another switch on this on PCB on this board, but these are the two we're going to be using. So we have the switch, a switch connected to RE3. There's a thing in the microcontrollers called the configuration switches. On AVRs, they're called something slightly different, but it is the configuration, these switches, they're software switches that control the operation of that particular port called RE3. It's called MCRLE, Master Clear. There are many different names for it, but let's just call it Master Clear. And if the pin is off, it's a Master Clear. It will reset the chip. And if it's on, you can actually use it as an input. But how do you do that? I mean, all these different, there are lots of different names. Look, even on my PowerPoint, I've got an E at the end of it, and sometimes there's no E at the end of it. Sometimes it's an underscore off, underscore on. There are so many different ways. I'm going to show you the easy way to do it. How you can change it from an input to a master clear or vice versa. So what we're going to do is we're going to initialize this chip. We're going to flash the LED, and if, depending on how we have set up the reset button, master clear, it's going to set the LED state, or it's going to reset the whole chip. So let's assume to start with that we have it as an input. An LED will change state because it won't reset the chip. And then if we have it as a reset, it will reset the chip each time and we will never get anywhere. So we're going to have these different states. So initialize flashing LED, that's I've just started the chip event effectively. And then if we have an input, we will get the ability to see an LED change state when I push the reset button. Otherwise it will loop around. And if it's a master clear or reset button, it will just do the first one, which is flash an LED. So we'll look at this. So what we're going to do is look at a thing called PICINFO, look at some sample code, review those results. So let's go into the IDE. Here it is. It's open. Fantastic. That's where I left it. I want you to press function key F4 and type in PIC, and it should list you PICINFO as the first info. It might not be. PICINFO might be the second. Now, user means it's a user added capability into this editor. Pick and press enter. So you can type the whole thing or not. It's up to you. Opens up this little window, and I'm going to zoom in on that so you can see it. I'm going to change the position on the screen. Drag that. Is that okay? Is that about the right size? Oh, perfect size. Look at that. Let me just show you how you can find things. It's already got the 1638 selected, but I'm just going to show you. Go to the search at the bottom, 16F1937, and it will take you to it. There's a lot. If you change it at the bottom, you can see that all the dialogues are changing to this other chip. I want a 7, so I'll go 7. You can also use the drop down. Notice there was a little utility window. That utility window has the first thing as PPS tool. It is grayed out. That means that this is not a PPS tool. That means that you do not have the option easily of changing the port assignments. A port is a port on a legacy chip, whereas if it was a PPS chip, you'd have a little bit more flexibility about how you use the ports. Quite important. If you want to go to what's called the Preferences editor or the IDE, you can take the next two buttons. Datasheet, just click on that, take you to the datasheet. Want to go to the website, the errata or programming datasheet, just select those. But what we're here to look at is the configuration options. These are the configuration options for this chip. That's the full list. This is quite a small set. Legacy chips historically don't have many configurations. And if you look in here, one is called MCLRE, Master Clear. And the default is off. So anything with a star is off. So like if you click in here, look, there's two options, on or off. Trust me, if I go to a different chip in here, let me just pick one down here. Is it Master Clear on or off? Let me take a newer chip for you. Where's Master Clear on or off? It's typical, isn't it? You know, when you want to find something. I was looking for some odd naming. I think in the 18s certainly have Q40. Master Clear. Let's have a look in here. Oh, there you go. Look, MCLRE, and it's called INT and Master Clear, which is off basically. But you can see that it's different. And if you notice, it says PPS tool is now active. That is a PPS chip, and it's capable. Now, I want to go back to my own chip, mine. There we go. Now we know from this that the Master Clear is set to off to start with. Well, what you can actually do is take a copy of the configuration, and it will put that in your cut and paste buffer, and you can use it in a program. Let's go do that. Let's go out to the editor, click on that, and if you open up the Explorer and take program 80, using the reset switch as an input, click shut down that by pressing Control B. or any other method that you'd like. And now we've opened up the program. What is different here is that we have what's called a hash config, and hash config changes the behavior when you program the chip. This is how you change the behavior, and you can type in all the ones you just saw listed for the 16F1937, or you can cut and paste them in. It's up to you. If you want to know what the differences are, go hunt around, look at PICINFO. It has all the options. I forgot to show you. If you go to this particular tab, let me just zoom in again. If you want to know what the options are, press on the tab options, and here they all are. Look, master clear. It can be set to off or on. All the other ones have all its values. Very useful PICINFO. So first of all, we're going to set it to off, and then we're going to set that to on. We're going to see what the difference is. Well, we're going to go look at these constants that have changed, and I've actually got a constant for the reset button. RST button on port E3 and set that to an input. As I said, this is set automatically. You can't actually change it. So a bit pointless really, but it's there for clarity. First thing we're going to do is flash one LED 20 times. And that's going to tell us when the chip resets. Then we have a for next loop, and it says if the reset button is held down, then change the state of the LED 1. If our other LED is pushed, look, remember the switch we had previously on called switch in? Let's go back to the constants. Switch in is on port A, that's the other switch, and it will also change an LED. It's going to, so we're going to toggle on a reset, we will toggle LED 0. If we push this reset button, we're going to toggle LED 1. And if we press the other switch, which we had up, LED 2. There is no debounce in here, by the way. I'll let you add that. So let's go out to the, see what's happening over here. It's just programming it. It just programmed it quite quick. So let's see what we've got. I'm just going to, we're not going to change the program, are we? We're going to see what happens. If I, how do I power cycle this? Let me power cycle the whole thing by taking the power off, and we should see the LED 0 flash 10 times, and it does. So we now know that when this chip boots, it flashes 20 times. If I press RA4, the button comes on, the LED comes on. If I press the reset, which is the left one, I get RB1 come on, which is this other LED. So we've got 3 LEDs here. This on the right will flash when we reset the chip. This will flash when I push the reset button, and that's clearly changing it. It's not crashing because it's not rebooting because the first LED is not being lit. Finally, RB2. Let's change our program. Up to the configuration, change that to on. Function key F5. Lots of different ways of doing it. I hope that you saw that on the screen. I would check that. I would do it again. I was looking at my screen, not the. There we go. I want to see that I changed that from an off to an on. I've disconnected the power. My mistake. You saw that. It's just the programming event failed. Not a problem. Just do it again. So previously, this LED here will flash once the programming. What? We've got power. It's worked in the past. It's not finding my programmer. What have I done? What have I done? What have I done? I'm just going to do that again. It's not finding the, it could be I have to unplug the USB. Oh, that's what I'll do. I'll just do that for, oh, there we go. It just burst into life because this LED here has just flashed. So I've now, sorry about that programming error. There we go. So we're going to see that flash 10 times. Great. And RB1's come on. That's a different behavior. That means the configuration in here has changed. Let me push RA4. That operates the same. If I push the reset button, because it's pulled high by the input, it resets the whole chip. But I've lost the input that was on here. I push the reset button now, it now resets the chip quite correctly. So the insight here is you can change the configuration. And if you wanted to change the configuration, any of the configurations, the quick way is to use PICINFO. You can take a copy of your changed, let me just show you what I'm doing. You can change the configuration in here. You can say I want to have some other type of oscillator. I want to move it to, I want to code protect it. Oh, there's a good one. Code protect, that's good. Take a copy of the configuration, copy. Go back to your source program. And you know that because you've done it in PICINFO, it's going to be correct. I can then come into here, delete what's already there, and Control V and paste it in. It has put in a completely different configuration, which you know will work. I'm going to put my program back as it was to off, reprogram it, and then we'll see what happens out on the chip. What we should see here is that this LED will go off because it's no longer pulled high by the reset function. LEDs flash 10 times. I've now got my 2 inputs back. So on this board, I've now got 3 inputs. This could be a reset. It can be an input. Fantastic. And PICINFO works. Back to PowerPoint. So we saw that. Seen it all working. Next time we're going to see we're going to use that switch. We're going to use the ADCs. We are going to use what else are we going to do? We're going to make them rotate. We're going to put values on the screen. It's just going to be great. Okay, so using the switch, ADC, make it all flash in sequence. Fantastic. Enjoy.